How to locate the image in a diverging lens. So diverging lenses are the ones that kind of look like an hourglass, okay, where they cave in the middle. And what happens is when the beam comes through, it spreads out or diverges. So the word diverges means spreads out. So it spreads out. That means if it's spreading out on this side, if I extend those this way, the primary focus is going to be on the left side. So whenever we have diverging lenses, the primary focus will be on the left side. So there's 3 image rules you can use to locate the image in a diverging lens. And what we'll find is these rules are all very similar. So a ray parallel to the principal axis is refracted as if it had come through the principal focus. 2. A ray that appears to pass through the secondary principal focus is refracted parallel to the principal axis. So we're going parallel F. Here we're going F prime, then parallel, and then the last one's always the easiest one. We just go straight through O. The image characteristics SALT are actually the same for every diverging lens. So images in diverging lenses can be described using the same characteristics as with converging lenses. We always talk about the SALT: size, attitude, location, and type. The image characteristics are always the same. So with this one, we know they always work out the same. It says no matter where the object is located relative to the lens. So in the converging lens, depending on where I put the object, I get very different results. As we saw with the last example, there was one on the right side, so it was real, and then one on the left side, so it was virtual. But here, they'll always be smaller, upright, on the same side of the lens as the object, and virtual, because it's the dotted lines that are meeting. So we always end up with the exact same thing. Examples. Describe the image characteristic SALT of an object that is 1 centimeter tall and 6 centimeters from a diverging lens and has a focal length of 2 centimeters. So we always draw the object on the left side. We're just going to be consistent that way. So it says it's 1 centimeter tall and 6 centimeters from the diverging lens. So I take my ruler and I line up 6 with the lens, put a little dot over here, and this is 1 centimeter tall. Next it says diverging. Well, in a diverging lens, what happens is it all spreads out on this side, so if I extended them this way, my primary focus is going to be on the left side. So when it says has a focal length of 2 centimeters, just pick a random number, count 2 centimeters over. So 1, 2, there's my F. And if I go 2 centimeters on the opposite side, I have F prime. So F prime, F. So in a converging lens, F is always on the right side. In a diverging lens, F is always on the left side. So that's something you have to keep straight in your head. All right. So the next thing we do is we can start drawing our lines. So the first one, what we're going to do is we're going to go parallel. And then when it hits the lens, we stop. And you turn your ruler, so now that it goes through F. So what happens in reality is the beam goes parallel, and then it refracts out like that. And we saw that. You're going to see that in class where it bends outwards. Now, I know it's these lines that are going to cross, so I'm going to just draw dotted ones on this side. So it's always the refracted beam that gets extended. All right, the next one I'm going to do in green. That's my green. Light green. There it is. All right, so the next one, we line up with F prime. And when you get to the lens, we stop. You lift your ruler off. We make it parallel. And this beam would go this way. Now, it doesn't actually bounce back. But if it did, it would follow that path there. All right, the last one we're going to do in blue. And this one goes straight through the optical center and back. And then just comes back and dotted on this side. So the 3 beams cross right there. So I'm going to draw that in pink. So my 3 beams, 1, 2, 3, cross right here. Right there. Now we write out our salt. So salt is S-A-L-T. And what we see is it is smaller. Attitude, well, it's pointing up just like this one, so it's upright. For location, well, it's between F and the optical center. Between F and O. This little point in here is my O. And type, well, it's the dotted lines that are all meeting. So that means it's actually virtual. This is our second example of a diverging lens. Describe the image characteristic salt of an object that is 1 centimeter tall, 1 centimeter from a diverging lens. So in the first example, I showed you what it would look like if the object were very far away. Now we're going to do it close, just to see if we get the same salt results. All right. So it's 1 centimeter tall, and it's 1 centimeter in front of the diverging lens. Now remember, diverging lens, hourglass, in skinny at the middle, and it spreads out, it diverges out. So there's no focal point on this side. If those spread out beams were extended, they would meet over here on this side. So this is where I'm going to draw my stuff. So the first thing I'm going to do is draw the object, because it is 1 centimeter from the lens. And I know it's 1 centimeter tall. Next thing it says it has a focal length of 2 centimeters. So I just finished saying that it's got to be on the left side. So my focal point is there at 1, 2. That means my F prime is going to be on the right side, 1, 2. So this is my F. O is in the center. This is F prime. Okay, I can start drawing now. So the first one is just parallel. Then I line it up with F. So I go parallel. I lift up my ruler and I rearrange it so that it's parallel with F. And what happens is the beam goes up. Now, if it were to come back, it would follow this path here that I'm drawing dotted. The next one I'm going to draw in green. So what we do is we line it up with F prime, but you stop at the lens. You just go from the tip of the object to the lens, and then you stop. You move your ruler. The whole page is moving. And then we go parallel. It's whatever goes through the lens is what gets extended on the other side. And then finally, we go through the optical center. So you take your ruler, line it up with the optical center, and we go down, and if we're to come back, we draw as a dotted line. Now, I see that my 3 lines cross here. So I'm going to draw my image in, and I can write out my salt. So salt is S-A-L-T. And I see that it is smaller again. It's also upright. Location, it's always going to be on the same side as your object, and it's between the O and the F. And again, it's the dotted lines meeting, so the object's actually, the image is not actually being formed here, so we say it's virtual. Because what's happening in reality is the beams are all being spread out on this side.